Africa released 3,000 tortoises that were on the brink of extinction into the harshest desert on Earth. It sounds unbelievable, but it's true. The Sahara is wrapped in extreme heat year-round, with temperatures reaching nearly 50 degrees Celsius and sandstorms powerful enough to bury life and hope within just a few hours. For decades, communities along the southern edge of the Sahara tried everything they knew to stop the desert's advance. But one project after another collapsed, leaving behind barren fields and livelihoods erased by season after season of failed harvests. Then, with nothing left to lose, a risky decision was made. They released some of the most ancient, slow-moving, and fragile creatures on Earth, hoping they might help save the land itself. Is this a bold ecological experiment, or a reckless choice made in the middle of a dying desert? Mandarin Tech reveals the full story in this video. On a map, the Sahara appears as a massive yellow expanse, but in reality, it is one of the most unforgiving environments on Earth, covering more than 3.5 million square miles and offering almost no mercy to any form of life. In the central regions, annual rainfall rarely exceeds 2 inches, and across the entire desert, it almost never goes beyond 4 inches. But even when rare rainfall does occur, the Sahara cannot retain water. Extreme heat drives evaporation to as much as 236 inches per year, dozens of times higher than the actual rainfall. Water barely touches the ground before it disappears, leaving behind cracked surfaces and scorching sand. This harshness is also evident in the daily day-night cycle. In some areas, temperatures can rise above 40 degrees Celsius, but once night falls, the air can cool rapidly to just 10 degrees Celsius or even lower. Under such conditions, simply maintaining stable human life is already a challenge, let alone farming or land restoration. The Sahara is not just a desert, it is a system that continuously erodes every human effort. Along the southern edge of the Sahara lies the Sahel, a transitional belt stretching up to 620 miles, where the desert begins to encroach on life. More concerning is that this process is accelerating. The Sahara does not advance like a moving wall of sand, but the surrounding dry and semi-arid lands are gradually degrading under the combined pressures of climate change and human activity. As fertile topsoil disappears, areas that were once farmable quickly turn into barren ground. Each year, the Sahel, including Mali, Niger, Chad, Senegal, Mauritania, and Burkina Faso, loses between 49,000 and 74,000 acres of fertile land, with roughly 90% of the population dependent on farming and livestock. Desertification here is not just an environmental issue, it is a survival crisis. To stop the Sahara and bring life back to degraded land, a group of African nations launched one of the world's most ambitious environmental initiatives, the Great Green Wall. The original plan was to plant a continuous belt of forest about 9 miles wide, stretching nearly 4,800 miles from Senegal to Djibouti, aimed at restoring 247 million acres of degraded land and creating an ecological barrier against desertification. But reality proved far harsher. By the end of 2023, only about 18% of the planned area showed meaningful progress, mainly in countries like Ethiopia and Nigeria, while many others fell far behind their original targets. The problem was not just limited funding or slow coordination. More fundamentally, large-scale tree planting has proven poorly suited to vast regions with scarce water. Young trees die from drought and strong winds. Long-term maintenance capacity is limited, and local communities have often been left out of the restoration process. As a result, many green walls either withered over time or were cut down for firewood when immediate survival needs outweighed long-term goals. As of mid-2024, only about 74 million acres have been restored, less than 1/3 of the original target. Clearly, additional solutions are needed to restore degraded land and slow the spread of the Sahara. For example, tortoises, not just any tortoise. Releasing the wrong species into the semi-Saharan region would only lead to quick death under such extreme conditions. But through millions of years of evolution, one species has adapted almost perfectly to arid environments. The African spurred tortoise, also known as the sulcata tortoise. This species can dig deep burrows to escape extreme heat, survive for long periods without surface water, and move continuously across barren terrain. Yet here lies the paradox. Even a creature this resilient has not escaped human impact. Today, the sulcata tortoise remains on only about 16.7% of its original range, largely due to large-scale livestock grazing. Cattle, sheep, and goats strip vegetation from the land, disrupt soil balance, and as the ground degrades, desert tortoises disappear with it. Some researchers believe that the absence of sulcata tortoises has broken critical ecological feedback loops, causing repeated failures in land restoration efforts near the Sahara. As a result, instead of focusing solely on planting trees, projects have begun reintroducing sulcata tortoises as a way to restore their lost ecological role. This approach is not unfamiliar. In North America, reintroducing bison helped revive grasslands, while beavers are considered ecosystem engineers for creating natural water retention systems. In many cases, bringing back a keystone species can be more effective than spending millions of dollars on technology. Returning to the Sahel, this region does not lack life. It lacks the conditions for life to return. And it is in this environment that sulcata tortoises begin to make a difference. With powerful front legs and large claws, they constantly tear into the soil like slow but relentless biological plows. In the Sahel, degraded land is often sealed by a hard surface crust, strong enough to block both oxygen and rainwater from penetrating the ground. When rain does fall, the water cannot soak in. Instead, it runs off the surface, carrying away the thin remaining layer of soil and accelerating erosion. Then the diggers arrive. Sulcata tortoises locally break through this hardened crust, creating rare entry points where water and air can once again reach the soil. But their impact goes far beyond the surface. To survive, they dig massive burrow systems, tunnels that can reach up to 30 meters in length and 15 meters deep. These burrows not only protect the tortoises from extreme heat and predators, but also unintentionally become natural soil restoration networks. When rain arrives, water flows into the burrows, seeps deep underground, and spreads outward. Oxygen follows, improving soil structure and biological activity. Over time, areas around the burrows retain moisture more effectively, allowing plants to take root. Small micro-oases begin to form within the dry landscape. Sulcata tortoises play another key role: seed dispersal. As they graze, they swallow seeds and carry them for days or even weeks before releasing them elsewhere, often directly into soil that has already been loosened. The seeds are deposited in nutrient-rich tortoise droppings containing nitrogen, phosphorus, and potassium, greatly increasing germination success. From these small starting points, insects appear, followed by insect-eating species. Tortoise burrows become shelters for animals that cannot tolerate extreme heat. Biodiversity slowly begins to return, one step at a time. Just as importantly, sulcata tortoises reproduce very well in captivity. Breeding centers can release hundreds of individuals each year without harming wild populations, turning tortoises not only into a tool for ecological restoration, but into a solution that can be scaled. So what actually happens when sulcata tortoises are reintroduced into the wild? Starting in 2006, the Ensemble Foundation began reintroducing sulcata tortoises into the Furlough Biosphere Reserve as part of a long-term monitoring program. Instead of releasing thousands at once, the tortoises were released in small groups and closely tracked over many years to assess survival rates, reproduction, and their impact on the surrounding environment. The early results were considered encouraging. Around 80% of the tortoises survived in the wild, an exceptionally high rate for wildlife reintroduction programs. Researchers also documented the presence of hatchlings, indicating that the population was beginning to sustain itself without constant human intervention. But the greatest value of this program does not lie in the numbers. It lies in the quiet changes taking place on the ground. Around tortoise burrow systems, soil retains moisture more effectively, vegetation appears earlier after the rainy season, and insect activity increases noticeably. These changes are not enough to turn the Sahel into a lush green landscape, but they are enough to show that sulcata tortoises are reactivating ecological feedback loops that had long been broken. This is not a miracle, nor a replacement for every other solution, but as the Sahara continues to press from the north and human pressure builds from the south, These small changes carry a powerful message. This land still has a chance to recover. Tortoises were not the only species brought back to the Sahel. Alongside them, an even more ambitious effort was underway, reviving a species once thought to have disappeared from the wild, the Addax, or scimitar horned oryx. For decades, the Addax had been nearly extinct in the wild. Hunting, armed conflict, and habitat degradation wiped them out across much of the Saharan Sahel. By the early 21st century, only a handful of individuals were believed to remain in the wild, and ecologically, the species was considered functionally extinct. Yet while they vanished from the desert, a small population survived quietly in conservation centers, in zoos across Africa, Europe, and the Middle East. For years, conservationists focused on preserving genetic diversity, restoring wild behaviors, and preparing for what once seemed impossible, returning the Addax to the lands they once dominated. In vast protected areas of the Sahel, the first animals were reintroduced in small groups, fitted with satellite tracking and closely monitored. They relearned how to move across sand, locate scarce food, and avoid predators, not in enclosures but in the open desert itself. The return of the Addax is not just about saving a species from extinction. As large grazers, they help regulate vegetation, disperse seeds, and rebuild ecological structures that once defined the Sahel. Like the sulcata tortoise, Addax do not green the desert, but they restore the broken links that allow ecosystems to function again. Alongside sulcata tortoises and the Addax, another species is quietly returning to this harsh land. The African ostrich, the fastest-running bird on Earth, and once an essential part of the ancient Sahara-Sahel ecosystem. In the past, ostriches roamed widely across the dry plains, traveling dozens of kilometers each day in search of food. But overhunting, armed conflict, and shrinking habitats pushed them out of many parts of the Sahel, leaving behind an overlooked ecological gap. As ostriches disappeared, a chain reaction followed. Seeds were no longer spread over long distances, insects and small animals lost shelter, and open land grew increasingly lifeless. Today, ostrich reintroduction programs are being carefully carried out in selected Sahel reserves. Unlike confined livestock, ostriches move constantly, compacting the soil, breaking hardened crusts, and unintentionally helping seeds reach moist soil beneath the surface. Their droppings, rich in organic matter, provide valuable nutrients in degraded land. Ostriches also act as mobile observation points within the ecosystem. Highly alert and quick to respond to environmental change, their presence often coincides with the return of other species, from insects and lizards to mid-sized predators. Like tortoises and antelopes, ostriches do not turn the Sahel green after a single rainy season. But each footprint, each nest, and each returning flock helps restart an ecosystem that once functioned steadily for thousands of years. Feral hogs are not native to North America. Hundreds of years ago, the continent had no massive wild hog populations like the ones seen today. They were brought here by humans, first by European explorers and later by early settlers, who released pigs into the wild as a form of mobile food for long journeys. Over time, some animals escaped, others were abandoned, and some were later crossbred with European wild boars imported for sport hunting in the 19th and 20th centuries. The result was the emergence of a particularly dangerous hybrid, large, intelligent, highly adaptable, and capable of reproducing at extreme rates. The southern United States, with its warm climate, abundant water, and vast open land, quickly became an ideal environment for their expansion. And nowhere has paid a heavier price than Texas, where feral hogs increasingly behave like an army without uniforms, without borders, and constantly pushing into new territory. Texas didn't discover a single secret weapon. What they built instead was a layered control system where each piece reinforces the others. Across the state, smart traps equipped with cameras and mobile connectivity have been deployed. Farmers set up large corral traps baited with corn, with cameras streaming live footage directly to their phones. Feral hogs move in to feed, completely unaware that every step is being monitored. Once the entire sounder is inside, the gate is closed with a single tap. From anywhere. Texas Wildlife Services used this exact system in Irving when hogs flooded residential areas near Champions Park. Residents had tried electric fencing, but the real breakthrough came from precise, real-time control. No waiting, no guessing. Action only when the moment is right. The difference is scale. Traditional traps often catch just one or two animals, or trigger too early. Smart traps allow operators to wait until the entire group enters, not picking them off one by one, but removing the whole population in a single move. The cost is significant. Initial setup can run into the thousands of dollars plus ongoing mobile fees and maintenance. But compared to replanting 160 acres of corn at roughly $400 per acre for seed and labor alone, many farmers realize a smart trap can pay for itself after stopping just one disaster. As a result, neighbors often split the cost, sharing systems to monitor multiple properties. These traps also require patience. Hogs must be trained over 10 days to 2 weeks. Gates are raised at first to allow free feeding, then gradually lowered. By the time the trap is fully operational, the hogs are comfortable enough to drop their guard. Still, Texas understands one thing clearly. Even smart traps aren't enough on their own. In fast-spreading hot zones, they needed something more aggressive, a tool that gives feral hogs no time to adapt. The Sahel is not being revived by massive projects or expensive technology, but by one of the slowest creatures on Earth, the sulcata tortoise. By digging burrows, breaking hardened soil, and helping water soak back into the ground, these tortoises are quietly restoring ecological processes that were once lost. They do not turn the desert green after a single rainy season, but with every step, they show that the land still has the ability to recover. If you found this story thought-provoking, please like the video and follow Mandarin Tech for more science-driven stories from around the world.